Good afternoon. My name is Sebastián Ocasio, and today I'm going to present my warehouse design project for the Logistics Systems course. This warehouse design project will explore various factors impacting the storage and management of 24 items. We start by evaluating high priority materials, rack capacities, align sprinkler systems, and conduct ABC analysis. Insight from ABC and pallet inventory analysis will guide our design, featuring 3 entrance doors and 4 exit doors for logistic optimization. The strategic warehouse floor plan will emphasize fire protection, accessibility, and efficiency. To start the ABC analysis, we must compute the total pounds per material used in order to determine the yearly cost per material. Such analysis is crucial for comprehending the financial implications of each inventory item. The cumulative weight of all materials is 13 million pounds, which is equivalent to nearly $150 million. Now we can conduct the ABC analysis, a method in inventory management that categorizes products into 3 groups based on their value to the company. A items, which there are 5 items, comprise of 20% of the inventory, are the most valuable and need strict control measures. B items, which there are 7 items, account for 30% of the inventory and require less strict warehousing conditions. And lastly, C items, which there are 12 items, consist of 50% of the inventory and are the least valuable and can be stored in standard warehousing environments. Once the materials have been categorized, the annual rotations can be implemented to calculate the average inventory in pounds. This inventory can then be converted into pallets, displaying the quantity to be stored at any given time. All pallets to be stored amounts to 9,539. However, for optimal warehouse utilization, it's advisable to design for a utilization rate of 85%. This suggests that the layout should cater to a total of 11,222 pallets to fulfill inventory needs, reserving 50% for potential fluctuations in demand. Racks requirements. A small financial analysis was conducted to decide on the types and sizes of racks to utilize, aiming for cost efficiency. I divided the pallet capacity of each item across both types of racks, considering their respective capacities and cost. Option 2, which is a 10 pallet deep 4-level high driving rack and a 1 pallet deep 4-level high conventional rack, emerged as the best choice as it offered the lowest cost at $1,636,656 compared to the other options. We possess a grand total of 11,222 pallets, which will be allocated as follows: 10,754 pallets in driving racks and 469 pallets in conventional racks. Our warehouse comprises a total of 269 driving racks and 59 conventional racks. Among the 24 materials stored, 13 are flammable, requiring additional safety measures for their storage. Flammable racks cost. For non-flammable items, a ceiling-type sprinkler system is imperative, covering the area above the racks. Conversely, flammable materials require inline sprinkler systems, meaning each rack level requires its own sprinkler device. As observed, we determined the square footage required for the sprinkler system based on the flammability of each material and rack area. The conventional rack area measures 4 feet wide and 8 feet long, while the driving rack area measures 5 feet wide and 40 feet long. The total square footage for the inline sprinkler system amounts to 93,000 square feet approximately, and for the seating sprinkler system, approximately 32,000 square feet. Now, before proceeding with the design of the warehouse layout, a preliminary financial analysis was conducted to evaluate the adequacy of the proposed number of racks, the square footage required, and the rotation plan. I opted to enhance inventory rotations, aiming to reduce space utilization and inventory cost. The rotations were adjusted to 12 rotations for A items, 8 for B items, and 5 for C items. Previously, there was a pallet capacity of 11,000, With these adjustments, the pallet capacity has reduced to 7,102 pallets, resulting in a reduction of more than 3,000 pallets. Due to the reduction in pallet capacity and the adoption of a 2-pallet deep conventional rack system instead of a 1-pallet deep setup, the number of driving racks decreased from 269 to 168, and the number of conventional racks decreased from 59 to 26, meaning that there is going to be a lower total cost per square footage for the sprinkler systems. Initially, the ceiling square footage was approximately 32,000 square feet, which has now been reduced to 20,000 square feet, while the inline square footage was initially around 93,000 square feet, which has now been decreased to 56,000 square feet approximately. As you can see, here's the comparison, the before and after, which is evident from the adjustments made that the cost has been reduced from nearly $7.5 million to around $4.5 million. Initially, a setup using a 1-pallet deep conventional rack system required the use of an 8-foot forklift at a cost of $25,000, rather than a 10-foot forklift at a cost of $30,000. However, with the transition to a 2-pallet deep conventional rack setup for the new setup and process, the 10-foot forklift becomes essential to reach the farthest pallet. Despite the higher machinery cost, the reduction in square footage and pallet count compensates for this increase. Here is the configuration of the warehouse detailing all dimensions. This layout occupies around 97,500 square feet of space and encompasses all the racks, an office space, 2 restrooms, and the utility room. Additionally, there are 3 entrances, each spanning 8 feet wide, and the 4 exit doors spanning 10 feet wide to facilitate product movement. The adequate spacing has been allocated between the racks to ensure convenient passage for forklifts, minimizing travel distances within the warehouse. Here is the total cost analysis. The table provides a detailed breakdown of expenses linked to establishing a warehouse infrastructure encompassing a range of items such as driving racks, conventional racks, sprinkler systems, forklifts, office space, restrooms, and a utility room. Each entry includes the quantity, unit price, and total cost. In summary, to set up the warehouse, a total of $4.7 million approximately is needed versus $8 million if the previous option was selected. In conclusion, this warehouse project optimizes storage and management for 24 items through strategic analysis. Initial projections estimated around $7.4 million in cost, but careful considerations led to a 38.6% reduction, saving around $2.8 million. ABC analysis categorized materials guiding management strategies. The layout design with 3 entrances and 4 exits ensures efficient material flow. Specialized safety measures for flammable materials were integrated, ensuring compliance with regulations. Overall, our data-driven approach achieves cost savings, operational efficiency, and safety compliance, setting a foundation for a continued excellence in warehouse management. Thank you for your time.